Hello, IK here. Welcome to JavaScript Engine Developer Continuous 6. And here is again stack. All our code go to from high level to machine language, and all that go in a memory heap in some place in memory. But when we have call, when function is called, would be created function frame on the stack, and inside that frame all other of that function. Here it is app function component. App function component have two child, add post form and post list. It means that first we have a frame when app would be called, would be created stack frame on stack for that function, and would be pushed. That function would be pushed from heap memory to stack, and after that would be push child component, add post form function, after that post list function. And look at only that tree. Of course, if post list and that post list, there is a child, post excerpt would be go also here. But we stay in this situation, and first in up, but last out. It means first execute, process or rendering post list. After that, add post form, and after that, up. It is recursive. Here is the acronym last in. Post list is last in stack, but first out. Recursive. Here is a functional component app.js. Functional component is function. And here there is an app calling add post form function component and post list function component. It is syntax for calling. Add post form would be called for calling post list. And we have app go first to stack, open frame on stack, and inside that open frame also open frame child JavaScript child components, functional component, add post form and post list, and execute after that, start execution, what we call rendering here in this situation, or it is named also for processing, and processing at first, processing add post form child, post list, or can we say like it is in stack? Yes, it is like this. Last in, first out. Okay, child component, after that parent. What if we have function factorial 5, factorial exclaim? We write it factorial exclaim equal 5 exclaim equal 5 multiply factorial 4. Here it is, factorial 4. Factorial 4. Factorial 4 equal 4 multiply factorial 3. Factorial 3 equal 3 multiply factorial 2, etc. And here it is, at first factorial 5 when would be called open frame on the stack, and inside of that frame open all what that function needed. That function need factorial 4, and would be open factorial 4 on the stack. After that, need factorial 3 would be opened on stack, factorial 2 and factorial 1. All that would be open, and now when it is all open, it means that stack growing, like push factorial 5, factorial 4, factorial push, always push on the top, and always pop up from the top. It means first would be execute factorial 1, because it is last in, first out. It is pop up. We have push factorial 5, push factorial 4, push factorial 3, push factorial 5, 2 factorial, push factorial. Now we have pop up or pull factorial 1, pop up factorial 2, pop up factorial 3, pop up factorial 4, and pop up factorial 5. And we have a result, because every of a function, when push on the stack, also push push place for location for return result. And we have every function, there is a return, and in the end, when was factorial 5 on top, we have a final result. It is a recursive execution. And what happened if we have factorial 1,000 or 10,000? Would be happen Stack Overflow. Now I have the demo for that. Here is one function, factorial n, and for example, here is a factorial 5, factorial 5, and we can see it is result. It is 120, and factorial 3. It is 6. Here it is 6, and factorial 1,000. Factorial 1,000. If infinity, and it is a Stack Overflow. There is no place in memory. There is no place in memory. Stack limit of memory, if don't exist, but exist in operation system, but don't exist because something we coding. It means that memory of my computers is full of stack, and it is overflow. There is no result. This is all for this video. Thank you for watching this video.